Hey guys, my name is Lakshay and I'm a research analyst at Scalar Academy, and welcome to another video of ours. So in this video, I will be telling about all the computer networking interview questions that interviewers will ask you during the interview. Now, have you ever heard about internet or net? I guess you have, and probably you are watching this video on the internet. But have you ever thought about the internet? So the internet is a network of all network connecting all network enabled devices which enable data and information sharing between them and makes computer networks a core part of life and technical interviews. So with this, let's see our top interview questions that interviewers will ask you. So let's see our first question. So the first question we have is, how are network types classified? So basically network types can be classified and divided based on the area distribution of the network. As you guys can see on the screen that we have first of all personal area network with square meter, then we have LANs, MANs, WANs, and finally the internet that consists of the whole planet. So that's how network types are classified. Moving on to our next question, explain different types of networks. So first of all we have PAN, that's personal area networks. In it, it lets devices connect and communicate over the range of persons. For example, it can connect Bluetooth devices in your mobile phone or your Bluetooth headphones as well. Then comes LAN. So it is privately owned network that operates within and nearby a single building like a home, office, or it can be a factory, or it can be your working area as well. Then there's MAN, and it connects and covers the whole city. So it's metropolitan connection. And for example, we have TV cable connections over the city. That can be an example for that. Then we have WANs, that's wide area network. So it spans around large geographical areas like country, continent. For example, if I want to communicate with my friend from Australia or Africa or USA, then it comes under WAN. After this, finally we have GAN, that's global area network, and it spans around the whole globe, and we call it as internet. It uses satellites, it uses network connections, and that's how the whole planet can connect to each other. Okay, so moving on to our third question, explain LAN. LAN is nothing but local area network. So LANs are widely used to connect computers or laptops and consumer electronics, which enables them to share resources like printers, fax machines, and even exchange information. So when LANs are used by companies or organizations, they are called enterprise networks. So there are two different types of LAN networks. Wireless LAN, it involves no wire connections, and we usually call it as Wi-Fi. Then we have wired LAN that we use LAN cable for. Then we have wireless LANs, and these are very popular for nowadays places where installation of wire is very difficult. So the diagram that you can see, we have an access point. Below access point we have Ethernet switch, and that's how we connect to Wi-Fi's and local area networks. Now moving on to our next question, the interviewer might ask you, tell me something about VPN. So VPN is nothing but virtual private network, and it is over wide area network that is built on the internet. So it allows creation of secure tunnel, which we mainly called as protected network between different networks using the internet or we using the public network. So by using VPN, a client can connect to the organization's network remotely. The diagram that you guys can see on the screen, it's an organizational WAN, and that is connected through Australia, creating using VPNs. Okay, so I hope you guys are understanding. After this, moving on to our fifth question, we have, what are the advantages of using a VPN? So there are few advantages of using VPN. Let me start off with the first one. So VPN is used to connect offices in different geographical areas remotely and is cheaper when compared to WAN connections. Next, VPN is also used for secure transaction and confidential data transfer between multiple offices located in different geographical areas. Then we also have VPN that keeps our organization's information secured against any potential threats or intrusions by using virtualization. And finally, VPN also encrypts the internet traffic and disguises the online identity. Moving on to our sixth question, what are the different types of VPN? So first of all, we have Access VPN. So Access VPN is used to provide connectivity to remote mobile users and telecommunicators. It serves as an alternative to dial-up connections or ISDN connections. It is a low-cost solution and provides a wide range of connectivity. Then we have site-to-site VPN. So it is also called as router or router-to-router VPN. It is commonly used in large companies having branches in different locations to connect the network of one office to another in different locations. Then we have intranet VPN. So intranet VPN is useful for connecting remote offices in different geographical locations using shared infrastructure with the same accessibility policies as the private WAN. So intranet VPN and extranet VPN are basically subsets of site-to-site VPN. So moving on to our extranet VPN, so it shares infrastructure over an internet like suppliers, customers, partners and other entities, and even connects them using dedicated connections as well. So these are the types of VPN. Moving on to our next question, what are the nodes and links? So node is basically a connecting device in a network. It's called a node. So node is a point of intersection in a network. It can send or receive data from information within a network. So examples of node can be computers, laptops, printers, servers, modems, etc. Moving on to link. So a link or a edge refers to connectivity between two nodes in the network. So it includes the type of connectivity. It can be wired or wireless between the nodes of protocols used for one node to be able to communicate with the another. Now let's see our eighth question. What is a network topology? So network topology is a physical layout of the network connecting the different nodes using the links. It depicts the connectivity between the computers, devices, cables, etc. So we have different types of network topologies. First of all, we have bus topology. So you guys can see on the screen on the left side. So all nodes are connected using the central link known as the bus, and it is useful to connect a smaller number of devices, and its main cable, if its main cable gets damaged, it will damage the whole network. Then we also have star topology. So here all nodes are connected to a single node known as central node. It is more robust, and if the central node fails to complete a network, it is damaged, and it is very easy to troubleshoot as well. Then we have ring topology. So each node is connected to exactly two nodes forming a ring structure. If one nodes are damaged, it will damage the whole network, and it is used very rarely as it is expensive and hard to install and manage. Then we have mesh topology. So here each node is connected to one or many nodes. So it is robust as failure in one link only disconnects that node, and it can connect through other nodes as well. So but it is very rarely used, and installation and management are very difficult here as well. And then we have tree topology. So it is a combination of star and bus topology, and it is also known as extended bus topology. So all these smaller star networks are connected to a single bus. So if the main bus fails, the whole network is damaged. Then we also have something called as hybrid, and it is a combination of different topologies to form a new topology, and it also helps to ignore the drawback of a particular topology and helps to pick the strength from another. So if you want to install routers or install some VPNs, you can use these topologies, and whatever fits best for you for the company, you can use that as well. Moving on to our ninth question, what is an IPv4 address and what are the different classes of IPv4? So basically an IP address is a 32-bit dynamic address of a node in a network. An IPv4 address has 4 octets of 8 bits. An IP address is a 32-bit dynamic address of a node in the network. An IPv4 address has a 4 octets of 8 bit, each having a number value up to 255. IPv4 classes are differentiated based on the number of hosts it supports on the network. So there are 5 types of basically IPv4 classes and are based on the first octet of IP addresses, which are classified as class A, B, C, D and E that you guys can see on the screen. So class A starts from 0.0.0.0 to 127. Then B class from 128 to 191, C 192 to 223, D 224 to 239, and finally E 240 to 255. And that's how IP addresses are classified. Moving on to our next question, what are private and special IP addresses? So private addresses, for each class there are specific IPs that are reserved specifically for private use only. This IP address cannot be used for devices on the internet as they are non-routable. Then we have special addresses. So here the IP range is from 127.0.0.1 to 127.255.255.255, and these are the network testing addresses, also known as loopback addresses at the special IP address. Now let's see some intermediate interview questions. We have describe OSI reference model. So OSI is Open System Interconnections. OSI is a network architecture model based on the ISO standards. It is called the OSI model as it deals with connecting the systems that are open for communication and with other systems. The OSI model has 7 layers. The principles that used to arrive the 7 layers can be summarized as it create a new layer if a different abstraction is needed. Each layer should have a well-defined function, and even each function of each layer is chosen based on the internationally standardized protocols. This leads to our next question: define 7 layers of OSI reference model. So first of all, moving from the bottom side, we have physical layer. So it is concerned with transmitting raw bits over a communication channel. It chooses which type of transmission mode is to be selected on the transmission. The available transmission modes are simplex, half duplex, and full duplex. Next we have data link layer. So the main task of this layer is to perform a raw transmission facility into line that appears free from undetected transmission errors. It also allows detecting damaged packets using the CRC cycle or error detecting code. So when there are more than one node is to be connected via a shared link, the data link layer protocols are required to determine which device has control over the link at what given time. Then we have network layer. So it controls the operation of the subnet. The network layer takes care of feedback messaging through ICMP messages. Then we have transport layer. So the basic functionality of this layer is to accept data from the above layers, split it into smaller units if needed, and pass these to network layer and ensure that all pieces arrive correctly at the other end. Then we have session layer. So this session layer allows users on different machines to establish a session between them. Dialog control is using the full duplex link as a half duplex. It sends out dummy packets from the client of the server when the client is idle. Then there is a presentation layer. So this layer is concerned with the syntax and semantics of the information that is being transmitted. It translates a message from a common form of encoded format which will be understood by the receiver. Then we have application layer. It contains a variety of protocols that are commonly needed by the users. The application layer sends the data of any size of the transport layer. With this, we have our next question: describe TCP/IP reference model. So it is a compressed version of OSI model with only 4 layers. It was developed by the US Department of Defense in 1980s. The name of this model is based on 2 standard protocols like TCP, that's Transmission Control Protocol, and IP, Internet Protocol. Moving on to our next question, define the 4 different layers of TCP/IP model. So we have 4 layers here. The first layer we have is link, that decides which link is such as serial lines or classic Ethernet must be used to meet the needs of the connectionless internet layer. Then we have internet. The internet layer is the most important layer which holds the whole architecture together. It delivers the IP packets where they are supposed to be. Then we have transport layer. Its functionality is almost the same as OSI transport layer. It enables peer entities on the network to carry on the conversation. And finally, we have application layer that contains all the higher level of protocols. Now after this, we have our next question: differentiate between OSI reference model and TCP/IP reference model. So OSI reference model, there are 7 layers of architecture while TCP/IP have 4 layers. Then we have fixed boundaries and functionalities for each layer in OSI, and we have flexible architecture with strict boundaries between the layers in TCP/IP. OSI is low reliability while TCP/IP is high reliability, and we have vertical layer approach in OSI model and we have horizontal layer approach in TCP/IP model. So these are the basic differences between both of them. Moving on to our next question, What are the HTTP and HTTPS protocols? So HTTP is Hypertext Transfer Protocol, which defines the set of rules and standards on how the information can be transmitted on the World Wide Web. It helps the web browsers and web servers for communication. It is a stateless protocol where each command is independent with respect to the previous command. HTTP is an application layer protocol built on the TCP and it uses port 80 by default. While HTTPS is the Hypertext Transfer Protocol Secure or Secure HTTP, it is an advanced and secured version of HTTP. On top of HTTP, SSL and TLS protocols are also used to provide security. So it enables secure transactions by encrypting the communication and also identify networks that serve securely. It uses port 443 by default. Moving on to our next question. What is SMTP protocol? So SMTP is nothing but simple mail transfer protocol. It is a set of rules for communication between servers. So this set of rules helps the software to transmit emails over the internet. It supports both end-to-end and store-to-forward methods. It is always listening mode on port 25. That's it about SMTP protocol. Moving on to our next question. What is DNS? So DNS is domain name system. It is considered as devices or services directory of the internet. It is a decentralized and hierarchical naming system for devices, services connecting to the internet. It translates the domain names to their corresponding IPs. For example, we have InterviewBit.com and its main port is 172.217.166.36 IP address. So that's how it converts it. And it mainly uses port number 53 by default. Moving on to our next question, what is the use of a router and how it is different from a gateway? So the router is a networking device used for connecting two or more network segments. It directs the traffic in the network. The information and data like web pages, emails, images, videos, etc. it transfers from source to destination in the form of certain packets. It operates on the network layer and the gateway are also used to route and regulate the network traffic, but they can also send data between two dissimilar networks while a router can only send data to similar networks. After this, I am going to tell you about some advanced interview questions. So first of all, we have what is a TCP protocol. So TCP or TCP/IP is a transmission control protocol and it is a set of rules that decides how a computer connects to the internet and how to transmit data over the network. It creates a virtual network when more than one computer is connected to the network and uses three-way handshake model to establish the connection between them and makes it more reliable. So that's it about TCP protocol. Next, relating to this, we have what is UDP protocol. So UDP is user datagram protocol and it is based on datagrams. Mainly it is used for multicasting and broadcasting. Its functionality is almost the same as TCP/IP protocol except for the three-way handshake and error checking. It uses a simple transmission without any handshaking, which makes it less reliable. Relating to this, we have another one more question, compare TCP and UDP. So as you guys can see, TCP is a connection oriented protocol while UDP is connectionless. TCP is obviously more reliable and UDP is less reliable, but UDP is very fast transmission and TCP is slow, and packets are preserved and rearranged in TCP while UDP just keep on sending packets without any reserved or arrangement. So there are three-way handshake model connection in TCP while UDP does not have three-way handshake, it just transmits the data. TCP packets are heavyweight while UDP packets are lightweight because it does not contain any security. Then we have offers error checking mechanism in TCP while there is no error checking in UDP. Some examples that we can give is like for TCP/IP we have protocols like HTTP. For TCP we have protocols like HTTP, FTP, Telnet, SMTP, HTTPS, etc. While for UDP, you guys must have heard about SNMP, RTP, BOOTP, TFTP, NIP, etc. These are the differentiation between both of them. Moving on to our next question, we have one more protocol, and that is what is ICMP protocol. So IPMP is the Internet Control Message Protocol. It is a network layer protocol used for error handling. It is mainly used by network devices like routers for diagnosing the network connection issues and crucial for error reporting and testing if the data is reaching the preferred destination in time. It uses port 7 by default as well. Moving on to our next question, what do you mean by DHCP protocol? Now DHCP is very important for interview, and DHCP is Dynamic Host Configuration Protocol. It is an application layer protocol used to auto-configure devices on IP networks, enabling them to use the TCP and UDP based protocols. The DHCP servers auto-assign the IPs and other network configurations to the devices individually, which enables them to communicate over the IP network. It helps to get the subnet mask, IP address, and helps to resolve the DNS. It uses port 67 by default. Moving on to our next question, what is ARP protocol? ARP is Address Resolution Protocol. As you guys must have heard about ARP, it is a network layer protocol used to convert the logical addresses like IP address to the device's physical address, and physical address is nothing but MAC address. It can also be used to get the MAC address of devices when they are trying to communicate over the local networks. So as you guys can see on the screen, that is basically how ARP works. It converts logical address to physical address so that they can communicate very easily. Moving on to our next question, what is FTP protocol? So FTP is nothing but a file transfer protocol. It is an application layer protocol used to transfer files and data reliably and efficiently between hosts. It can also be used to download files from remote servers to your computer. It uses port 27 by default. Moving on to our next question, what is the MAC address and how it is related to NIC? So MAC address is Media Access Control Address. It is a 48-bit or 64-bit unique identifier of devices in the network. It can also be called as physical address embedded with network interface card, that is NIC. And NIC is used as a data link layer. NIC is a hardware component in the networking device using which a device can connect to the internet. So that's MAC address is always compulsory to connect to the internet. Moving on to our next question, differentiate between MAC address and IP address. So first of all, MAC, it's main thing, media access control address, and IP is internet protocol address. So MAC address is 6 or 8 byte hexadecimal number, while IP address we have IPv4 and IPv6 that have 4 or 16 byte address. A MAC address is embedded in NIC, while IP address is obtained from a network or DHCP. A MAC address is a physical address and IP is a logical address. Then MAC address operates in data link layer, while IP address operates in network layer. And MAC address helps to identify exactly which device is connected to internet, while IP address identifies the device connectivity of the network. Moving on to our next question, what is a subnet? So a subnet is a network inside a network achieved by the process called subnetting, which helps divide a network into subnets. It is used for getting a higher routing efficiency and enhances the security of the network. It reduces the time to extract the host address from the routing table as well. So that's the basic thing about what subnet is and how subnetting is done. Moving on to our last question, compare hub and switch. And this is the most important question that you guys need to know, and people will ask this. Nowadays we don't use either hub, but we use advanced version of switches. So basically hub operates as physical layer while switch operates as data link layer. Hub is half duplex while switch is full duplex. In hub, Ethernet devices can be connected and it can be sent, while in switch LAN devices can be connected. Then we have hub, and it's very less complex, less intelligent and cheaper, while switch is intelligent and effective. We call it switch was basically made hub with a brain. So that's why the difference come into the picture. So no software support for administration in hub, while switch always have a administration support. Hub only gives you speed less than 100 Mbps, while switch supports high speed in Gbps. Then hub is very less efficient as there is no way to avoid collisions when more than one node sends the packet at the same time, while switch is more efficient as the collisions can be avoided or reduced as compared to hub. So that's it about this session, guys. If you have any question, any queries, put them in the comment section below and we will always be ready to help you guys. Until then, stay tuned for more from Scala.